the spacecraft that touched the sun, standing only a few million miles away from the surface of a star, not just any star. The sun, a giant sphere of nuclear fire so powerful that every second it releases more energy than humanity has used in its entire history. Now imagine flying directly into its atmosphere. Not around it, not observing it from a safe distance, but diving straight into the inferno itself. For decades, scientists dreamed about doing exactly that. Most believed it would be nearly impossible. The heat was unimaginable. The radiation was deadly. And the sun's gravity would pull anything that came too close into destruction. Yet on Christmas Eve 2024, a machine no larger than a small car achieved what once seemed impossible. NASA's Parker Solar Probe entered the sun's outer atmosphere, the corona. Traveling at over 430,000 miles per hour, it became the fastest object ever built by human hands. For more than a day, Earth heard nothing, no signals, no messages, only silence. Scientists could do nothing but wait. If Parker survived, it would reveal secrets hidden since the birth of our solar system. If it failed, decades of work would disappear into the sun forever. What happened next changed solar science forever. Why the sun's corona makes nitrogen monoxide sense. The sun has a mystery that has puzzled scientists for generations. Common sense says that the farther you move away from a heat source, the cooler things should become. Stand near a fire. Move away, the temperature drops, simple. But the sun doesn't follow this rule. Its visible surface reaches about 10,000 degrees Fahrenheit. Yet above that surface lies the corona, a vast atmosphere stretching millions of miles into space. And somehow, the corona reaches temperatures exceeding 2,000,000 degrees Fahrenheit. That's over 200 times hotter than the sun's surface itself. It shouldn't be possible. It's like walking away from a campfire and finding the air around you hotter than the flames. For decades, nobody knew why. This became one of the greatest mysteries in astrophysics, and there was only one way to solve it. Go there. The man who dared to ask. In 1958, a young astrophysicist named Eugene Parker proposed something radical. He suggested that the sun continuously releases streams of charged particles into space. At the time, many scientists thought the idea was absurd. Some reviewers even recommended rejecting his paper completely. But Parker was right. Those streams became known as the solar wind. Today we know that solar wind fills the entire solar system. It shapes planetary atmospheres. It creates auroras. It can even damage satellites and power grids on Earth. Decades later, NASA made an unprecedented decision. For the first time in history, a spacecraft would be named after a living scientist, the Parker Solar Probe, a tribute to the man who first imagined the invisible winds flowing from our star. Building a machine to survive a star, getting close to the sun isn't mainly a heat problem. That sounds strange, but space itself is nearly empty. The real challenge is surviving the intense radiation pouring from the sun. Engineers developed a revolutionary thermal protection system, a shield just a few inches thick. Made from carbon composite materials and carbon foam, light enough to launch. Strong enough to face temperatures around 2,500 degrees Fahrenheit. The shield would always point directly toward the sun. Behind it, the spacecraft's instruments could remain near room temperature. Imagine holding an ice cube a few feet behind a blast furnace. That's essentially what Parker was designed to do. Every second of the mission depended on that shield. One mistake, one wrong orientation, and the spacecraft would be destroyed in moments. The long fall toward the sun. Here's another strange fact. Getting to the sun is harder than escaping the solar system. Earth moves around the sun at roughly 67,000 miles per hour. To reach the sun, a spacecraft must cancel much of that enormous sideways speed. That requires an incredible amount of energy. NASA solved the problem using Venus. Again and again, Parker flew past the planet. Each flyby stole a little momentum, like tapping the brakes on a cosmic highway. 7 gravity assists over 6 years gradually pulled the spacecraft closer and closer to the sun. With every orbit, Parker entered territory no spacecraft had ever visited before. The closer it got, the faster it moved, until it reached speeds beyond anything humanity had ever built. Christmas Eve 2024, December 24th, Mission Control watched as Parker approached its closest encounter. Only 3.8 million miles above the sun's surface. To put that into perspective, Mercury, the closest planet, stays about 10 times farther away. No spacecraft had ever ventured this deep, then communication stopped. This wasn't a failure, it was expected. During the encounter, Parker could not communicate with Earth. For approximately 36 hours, scientists waited. The spacecraft was completely on its own. If anything went wrong, nobody could help. No commands, no corrections, no rescue. Just a tiny machine racing through hell at over 430,000 miles per hour. And then, the signal returned. Parker had survived. What IT found inside the sun, the data shocked scientists. Parker flew through structures that had only existed in theories. It observed massive magnetic switchbacks, violent twists and folds in the sun's magnetic field. These structures appeared to accelerate particles throughout the solar wind. The probe also passed through regions where the solar wind was still forming. For the first time, scientists could directly observe the birthplace of the solar wind itself. Even more surprising, Parker discovered that the boundary between the sun and interplanetary space is far more complex than expected. The corona was alive, dynamic, violent, constantly reshaping itself. Instead of a smooth atmosphere, scientists found an ocean of magnetic storms and energy flows. A hidden world never before explored. Why this changes everything? Most people think the sun only affects daylight and weather, but the reality is far more dramatic. Solar storms can disable satellites, disrupt GPS systems, interrupt communications, damage power grids, and threaten astronauts in deep space. Modern civilization depends on technologies vulnerable to space weather. The better we understand the sun, the better we can predict these events. Parker's discoveries are already helping scientists improve forecasting models. In the future, warnings could arrive earlier. Satellites could be protected, power systems could be prepared. Entire industries could avoid billions of dollars in damage. What began as a mission to answer a scientific mystery may ultimately help protect life on Earth. UTRO. For thousands of years, humanity looked at the sun and wondered. Ancient civilizations worshipped it. Scientists studied it. Telescopes observed it. But no one had ever touched it. Until now. A machine built by human hands crossed a boundary once thought unreachable. It entered the atmosphere of a star, survived, and returned with secrets hidden for billions of years. The Parker Solar Probe reminds us of something extraordinary. The universe still contains mysteries waiting to be explored. And sometimes, the only way to find answers is to fly directly into the fire.